Okay, Deirdre, let's see. Got it. So I hit share screen. Is that what I do?
I can do that. Hold on. Okay. You're good to go.
Do I
And
hit share
everybody,
screen?
would you please mute yourselves, or I can mute you if you don't know how to do it.
Give me a sec here. It looks like it's betwixt and between. So I'm going to go to the first slide before I go to slide share. Come on. And back here. Oops. Oh, here. Hi, so Lisa. My daughter's on. I told her it would make me nervous if she participated. Share screen. Is that what we want, Deirdre?
Yes, I can see it. I can also see all your
but I have to go to here.
Slideshow or something. Here we go. Perfect.
Yeah. Well, so I have a couple of thank you people for tuning in. I think it's well, I'd say it's definitely a worthwhile story. There are some minor complications because it's I would say it's science-based, and it's a realm that some of this is not any of my specialty, but it's quite interesting. And certainly it's possible I'll get a few things not 100% correct, and if you catch it and want to call me on it either in chat or anytime, or send me an email. But overall, it's an interesting story. And so a couple of disclaimers I wanted to offer is, for one thing, I'm not presuming to tell anyone what spirituality is. Somebody took offense right away that I put spirituality in the title. And but you'll see that it leads to a thin edge of science and a planet and a universe that we do not fully understand. I think some of this is going to sound a little bit like creationism in the classic sense that we think of it, and that like there is some sort of a God who looks like an old man, has a white beard, and he lives in the clouds and has made these arrangements for us. And that's not what I'm talking about. It's not my responsibility that the universe is exceedingly orderly, as I will offer you some evidence. You can agree or disagree, but it does not suggest really that there's a God. The other possibility is we don't understand our universe, and maybe the power of the universe is beyond our comprehension, and that comes up several times. So I'm going to mention there is this phenomenon that comes up in big history called the Goldilocks effects. And scientists actually will use that term, the Goldilocks effects, and they just mean that the planet is strangely amenable to life. There are levels of precision beyond comprehension that make life possible. And a few of those come out in the slideshow. And there, I show one picture of a book in the slideshow called the Goldilocks effects. I'm sure it's in many books, but I'm just mentioning, everything for Goldilocks, everything was just right. Everything in many ways is just right for life on Earth. That doesn't mean life is a bowl of cherries by any stretch of the imagination. The text of this talk, not exactly, but the overall story is at the MetaNaturalist website if you want to look at it. And so if I were, I debated whether to put this in, but if you want an abbreviated definition of spirituality in terms of where this is going. Yes, I weighed putting this in, but this line I think is a good line. Spirituality is just getting our minds off of ourselves. Now that's a little bit of a poke in the eye, but it's a good point. And the other thing I wrote down is think less, observe more, and breathe well. That's it. We're not going to any deeper spirituality than that. In a way, the scientific information does go deeper. But that would be the summary situation, and I'll maybe mention this again at the end. So this looks like the sun from space, but actually it's a human fertilized egg. And I start with it because it might be an example of the almost miraculous nature of our planet, of life on the planet. So we all started this way, a single cell. We started as a single cell. It's 1/10 of a millimeter in diameter, the width of a human hair, not the length, but the width. And it contains all of the genetic information necessary to grow to term in the uterus, be born, grow through childhood to adulthood, and to age. All the information is in that egg. That's, incomprehensible as far as I'm concerned. This is actually a picture of our sun, and it's also difficult to grasp. It's 93 million miles away, and yet it heats the earth almost perfectly. It's 27 million degrees in the middle. It would roast us if we got too much of that heat, but somehow everything is just right with the sun. It is 865,000 miles in diameter. So I like to ask kids, I have asked kids at school, what's it burning? Do you think it's burning firewood, or do you think it's burning coal? And what it actually is burning, as you may or may not remember, is it's fusing hydrogen into helium with a slight loss of mass in the process. The helium weighs a little less than the hydrogen elements that are fused, and that mass is transformed into energy, and that's the energy that we feel. There was a fact here where, if I can, the sun produces, in 1 second, the sun produces enough energy for 500,000 years of the current needs of human civilization. In 1 second. Enough energy. So where's that energy coming from? It's fusing 600, these numbers. I mean, they're impressive, and we don't need to know them. 600, it's fusing 600 million tons of hydrogen into helium per second. And so there's that little bit of mass missing in the helium that has been transformed into energy, according to this formula that we've all heard of, that was somehow divined by Einstein, equals mc squared. Energy equals mass times the speed of light squared. That is so strange. And here's how Einstein figured that out. First, he tried E equals m times a squared, and that didn't work. E equals m times b squared. And then E equals m times c squared. And he realized that was the secret to the universe. Well, that's just a joke. It's just a joke. C stands for the speed of light squared. So the speed of light is 186,000 miles per second. We're talking about quite an orderly universe here. And that's a law. Light will always travel at that speed. So, atoms, I think maybe sometimes we glaze over a little bit as soon as we start to talk about these things that are so minute that we're certainly never going to see them. But I think this material is fairly easy to get a concept of, that's understandable for us. I don't know how accurate it is. Even this image of a atom, of a hydrogen atom, which has 1 proton. Sometimes it has a neutron and sometimes it doesn't. All the other ones have neutrons. I don't know why hydrogen often doesn't. But protons and electrons, they're very different sizes. Protons are enormously larger, but they have the same electrical charge. And we know that we have this model, the electron orbits around the nucleus that holds the proton. So that's the model of a hydrogen atom and a helium atom. So hydrogen is being fused into helium, which has 2 protons. This is not difficult, and 2 electrons in the first electron shell, that first shell. There are other shells in other elements. So we're talking about something quite small here. You can fit 500 trillion hydrogen atoms on the head of a pin, and every one of them has this intricate order to it. It's beyond comprehension. This is a takeoff on Easter. Happy Oestry. And I bring it up because Easter is about the idea of being born again or of coming back to life. And actually, Easter is based on spring. Easter is a Christian adaptation of a celebration that humans observed long before there was any Christian religion, and it is a celebration of the renewal of life in spring. And I think it relates to this human drama of waking up, to whatever degree we wake up, waking up to the actual world. Somebody is not muted and is talking.
I just muted them.
Okay, good. So Einstein, so this world that we have to wake up to, he said the human mind is not capable of grasping the universe. I don't think we initially get that. I mean, there's even these tidbits I put out that the sun is burning 600 million tons of hydrogen per second. I mean, give me a break. There's no way we can understand that kind of dynamic. The human mind is not, this is Einstein, not capable of grasping the universe. We're like little children entering a huge library. The walls are covered to the ceilings with books of many different tongues, in many different tongues. He's not talking about languages. He's talking about the living world, the dynamic world, the biological world, the geological world that is so dynamic and so full of life. It's beyond us. The child knows something must be written in these books, but he doesn't know how that writing happened. All this intricate order, it does not understand the languages in which it's written, but the child notes a definite plan in the arrangements of the books, a mysterious order which it does not comprehend. So Einstein's referring to the intricate order of the universe as illustrated by these hydrogen atoms, where you can fit 5 billion on the head of a pin and they're all very orderly. So science, I'm not questioning science in any way, but science has its limits. So, and the Big Bang illustrates that in a sense. So one scientist, as a joke, characterized the Big Bang. He said, first there was nothing and then it exploded. That makes no sense, of course, but the Big Bang in many ways makes no sense. And so here's the old man in the cloud about to gonna make a Big Bang with his bang-o-matic. And so I have this good commentary by a biologist, now deceased, named Terence McKenna. And he says, the idea of the Big Bang is hard to swallow. There's the notion that the universe, for no reason, sprang from nothing in a single instant. Notice that this is the limit test for credulity. I mean, we tend to just accept it, but everything sprang from nothing in a single instant. How rational is that? Whether you believe this or not, notice that it is not possible to conceive of something more unlikely or less likely to be believed. It's the limit case of unlikelihood that the universe would spring from nothing in a single instant for no reason. So what science is saying is give us one free miracle and we can take it from there. So I say, and this is Terence McKenna speaking, I say if science gets one free miracle, everybody gets one free miracle. It's a good point. So speaking of an orderly universe, this is once again our little hydrogen atom with one proton and one electron in the orbital, in the electron shell. Well, as fate would have it, that electron shell in hydrogen holds 2 electrons. And there is a proclivity, a tendency on the part of that hydrogen to seek a second electron. And so I put in the second electron. That hydrogen atom is electrically speaking a little bit unstable, and will seek to share electrons with other elements to stabilize that first orbital, which holds 2 electrons. So I put a second electron in there just now. The first orbital only holds 2. So if the next element, which I forget, lithium maybe, it has to start a new electron shell. So here's oxygen, which has 8 electrons. The first 2 electrons go in the first shell, and it's full because it holds 2. The other 6 go in the second shell, but the second shell holds 8. Now we're talking about an intricate order that is beyond comprehension. Remember, 5 billion of these will fit on the head of a pin, and they all have this order built into them. Oxygen, the second electron shell holds 8, but it only has 6. So how many does it need to feel electrically stable? It needs 2 more electrons. What if it were to form an electron union with hydrogen and share electrons? What would you get? If hydrogen wants 1 electron, oxygen wants 2. If it shared with 2 hydrogens and 1 oxygen, all the electron shells would be full, and you would get water. H2O. They're sharing the electrons, and all the electron shells are full. This tendency to form molecules and compounds is built into the order of the universe. I mean, I put into the page in the Naturalist, it says the rest is history. The rest of the evolution of the universe is history, because it doesn't stop with water. In fact, I think coming up is a periodic table. So there's 92 of these elements, and a lot of them have unfulfilled electron shells. But this orderly appearance of molecules joining together is built into the structure of the universe. And this is just a picture of how snowflakes go together with the electrical force of oxygen and helium pulling one another together. So here's a periodic table. I must say it's always daunting to see it, but we can start out easy. At the top left, I'm circling it. There's hydrogen with its 1 proton and 1 electron, and over on the right, helium with 2 protons and 2 electrons. So remember that helium has its outer orbital. It only has 1 orbital, but it's full. It has 2. That whole row are inert. They don't react with anything because the electron shell is full. We're not trying to understand chemistry. I'm just saying this order is built into the universe. None of those gases, the noble gases, will react with anything because their electron shells are full. But none of those other elements are full. They all want the electrical tendency to react with other elements is built into the element itself because of these unfulfilled electron shells. So I'm going to pull up a 2 here. That's over the top of the O, oxygen, in the, I'm trying to read that row there. I think it's the 16th row. Everything in that column, so below oxygen is sulfur, it's also missing 2 electrons. That's the orderliness of this. If I have some other numbers I'm pulling out. Oh, sorry. I went to the left. Nitrogen is missing 3 electrons in its outer orbital. Carbon is missing 4. Boron is missing 5. See, the whole periodic table is put together in this way. It expresses the order of the universe. And I would say the inevitability of the evolutionary journey, if you can see what I'm talking about, because they all have this tendency to join together with other elements. It just takes a while. So here's a picture of the periodic table 14 billion years ago. Seriously, there was only hydrogen and helium in the universe 14 billion years ago. The other 90 elements did not exist. So where did they come from? Because our bodies are not not made up of any helium and maybe 5% hydrogen, but our bodies are made up of elements that did not exist. The universe is emergent and the universe is never done. I mean, I think about that, with the aspects of life that are troubling to us now. The universe is never done. It's in motion. It's just a little too slow for us at times. So this is a primordial gas cloud in the first second of the appearance of the universe. There was only hydrogen and helium, but now we have 92 naturally occurring elements. Where did they come from? The other 90 naturally occurring elements in that periodic table were formed in the center of stars. So those red ones there, that's carbon with 6 protons, nitrogen with 7 protons, orderly, oxygen with 8 protons, 8 electrons. They came from the fusion of hydrogen and helium. How many hydrogens would it take to make a carbon? I mean, the easy answer is 6. Then you'd have 6. If you would fuse them together, you'd have 6 protons. That's not quite how it happens, but it's close to that. It's close to that. Our sun is a red giant star and is fusing hydrogen and helium into carbon, nitrogen, and oxygen. It takes larger stars called hot blue stars, and I don't know if some of you would know the star Arcturus that twinkles blue in the sky, literally twinkles blue because it's a vastly bigger star than our star. But that means it has more heat and more pressure and can make larger elements. It's an emergent universe. Our life in our solar system and on our planet could not exist if there was not a preceding 10 billion years before our solar system formed and these elements were created in the center of stars, and then beyond iron, which is at the bottom there with 26 protons and 26 electrons, in supernova explosions. That's where the other elements came from. So what's the summary of this? The elements in our body were made in the center of stars. And we are, life itself and human life is an emergent property of the universe. So I mentioned Goldilocks. Here's Goldilocks is reappearing. Everything is just right. Well, how much of everything is just right? Well, some strange aspects of the universe are just right. So we're going to briefly talk about the creation of the moon. This is a hypothetical drawing diagram of how the moon was formed, and it's pretty well agreed this is how it formed in the early universe. Excuse me, the early solar system, 4.5 billion years ago, when the solar system was forming. It was dirty out there. There was a lot of debris. If you think of looking at the surface of the moon, it's pockmarked with meteor strikes and asteroid strikes. So earlier in the formation, there were larger bodies of accreted material, including things they call planetesimals. So it's thought that the moon formed. The Earth's moon formed when a planetesimal, maybe a quarter the size of the Earth, smashed into the Earth and drove part of the Earth's crust out into orbit around the Earth, which then accreted into the moon. So if there was no life on the Earth at this time, this is 4.5 billion years ago, but it was still a major act of violence. If that act of violence had not occurred, there would be no moon, which means there would be almost no tides. Most of the Earth's tides are formed by the moon. Even the sun is vastly bigger. It's 93 million miles away, and the moon is quite close. So there would be no tides. Well, tides are an element of the great diversity of life because it causes this interaction of the sea and the land and the mixing of nutrients. So without that collision, life would be far less diverse. Without that collision, it's thought that collision remelted the Earth and allowed much of the iron to migrate to the Earth's core because it's dense. It's a dense element. It migrates to the Earth's core. That iron in the Earth's core creates the Earth's magnetic field. Without the Earth's magnetic field, life on land would not be possible because that magnetic field blocks cosmic radiation, which is damaging to living cells. You could maybe live in the water, but not on land. So without that collision, no magnetic field. Without that, the Earth is tilted 23 degrees to the sun. It's tilted because that planetesimal smashed into it and knocked it off its vertical axis in relationship to the sun. So it's 23 degrees. So without that tilt, no seasons. There would be no spring and no winter. It'd all be the same. It's thought that it probably blew much of the Earth's original atmosphere out into space. There'd be 1,000 times more carbon dioxide. It'd be too hot for life. And it's possible it blew enough of the crust would be thicker and the plate tectonics would not occur. So the point here is this massive collision, which was so violent that it reheated the Earth, was a Goldilocks effect. It made life just right. It's a mystery. It's just a mystery. This is another Goldilocks effect that we live in the habitable zone. Too close to the sun, another 100 closer. Well, we're 93 million miles. Certainly a million miles closer to the sun to be too hot. A million miles further from the sun to be too cold. And we happen to live in a zone where water can exist in 3 states, water, gas, and frozen in this particular zone that we're in, the habitable zone. So people write about this. Scientists ponder this, the Goldilocks enigma. Why is the universe just right for life? I haven't read this book. I would like to read it. I mean, I don't think he can answer that question. Why? So we were talking about the macrocosm, the universe, and this large form. But when you talk about life, it's more of a microcosm. Bacterial cells are minute. I have it written down. I forget the size, but they are very small. But it's been said that they are as complex as a 727 jet. There's, the biological activity that goes on inside the cell is phenomenally complex. Well, it turns out that, we think of the human body is made up of about 50 million human cells, which are not bacterial cells. They're a lot larger than bacterial cells, but our bodies are completely covered by bacteria, the skin, the internal organs. So we have 50 trillion human cells. These are estimates, 80 trillion bacterial cells, and 30 trillion virus particles. I mean, the human body is an ecosystem. We could not live without the bacterial cells that help the functioning of our organs and very much help break down the food that we eat. And we probably could not live without the virus particles, the majority of which are bacteriophages, which are feeding on the bacteria. So we're walking ecosystems. So why do we breathe? I find it interesting that I would say most people do not know why we breathe. We know we breathe for oxygen, but what does the oxygen do? So it has in here, and I underlined it, it says we breathe oxygen to make energy. And I think that is not right. I put at the bottom, oxygen does not make energy. The energy actually comes from the sun, that the oxygen may be involved in our bodies. But that oxygen, that energy that's in our bodies was originally captured by the process of photosynthesis. And it's a stunning process. And we know the basics. We know that leaves take in carbon dioxide from the atmosphere, water from its roots. And I have the formula here. So there's the carbon dioxide, water. Leaves are able to break apart that water molecule, H2O, separate the hydrogen from the oxygen, release the oxygen into the atmosphere. The atmosphere is 21% oxygen. There would be no oxygen in the atmosphere if it weren't for photosynthesis. Oxygen is a very reactive element, one of the most reactive. And we're talking about an electrical tendency to join with other elements and change the chemistry of those other elements. And so then the hydrogen is attached to the carbon dioxide and it makes sugar. The photosynthesis makes sugar. I put a little energy sign there at the sugar because it stores the energy of the sun in the hydrocarbon bond, carbon hydrogen. I'm not sure what the oxygen does in sugar. Never figured that out. But the energy is stored in the carbon hydrogen bond. If that hydrocarbon bond is introduced to oxygen, which has been released to the atmosphere, it will release the energy of the sun that was captured in photosynthesis in that hydrocarbon bond. So this is a diagram of the 6 kingdoms of life and the estimated weight, dominance, non-dominance of these organisms. So my point at the moment is look at the dominance of plants. If you were to weigh, so those are gigatons. I think what, well, trillions, a gigaton is 1 trillion pounds. A gigaton is 2 trillion pounds, I think. So 450 gigatons of plants, it says carbon, but it's really the whole plant. 900 trillion pounds of plants on the planet. Everything else is subsidiary, is secondary. In fact, plants are the primary, well, they're not they're primary photosynthesizers. There are also other photosynthesizers. The algae are also photosynthesized quite a bit, but they're capturing the energy of the sun. There would be no animals. Animals cannot create their own energy. They can only release the energy captured by plants, and it's the energy of the sun. So I put that little energy sign in there. So there's 900 trillion pounds of plants on the planet. That's a picture of a tropical rainforest. Here's your pop quiz. Where did it come from? And it's interesting how, I mean, you might know the answer to that, you might not, you might have heard me talk about it in the past, but people generally, the life around us, we're not very curious. And to the credit of science, it has figured this out. And the answer is most of that biomass, 900 trillion pounds, is coming from the atmosphere. The biosphere is appearing from the atmosphere. Very little of it is coming through the roots of plants. And I put here, just ask any MIT graduate. And here's a picture of an MIT graduate from this little film on YouTube, Photosynthesis at MIT. If you want to watch something entertaining, and the short form is 3 minutes long, Photosynthesis at MIT, this scientific team goes to the graduation, a graduation ceremony at MIT, and they hand these graduates a seed and a piece of firewood. So that graduate's holding a piece of firewood, and they ask him, well, where it started out as a seed, where did all this biomass come from? And the MIT graduates say dirt, that the trees are sucking up dirt. I mean, shouldn't there be a big hole at the base of every tree if trees are sucking up dirt? There is no hole at the base of tree because the biomass on the planet is created out of carbon dioxide in the atmosphere, which only exists at 400 parts per million. So remember, we were talking about miracles. It's miraculous. We don't have to call it a miracle. That might be offensive. But the planet is miraculous. This is the tree of life with 6 kingdoms on it. Life started out with one. It's thought that life appeared on the planet one time. Science has never figured out how it started. It's thought that the first organism on the planet was a zucchini. That's a joke. But it comes from the fact that statement some of you have heard me read by a Unitarian minister. He said, fundamentalists are offended that science says we're related to monkeys. The fact is we're related to zucchinis, which is true. We are related to zucchinis because life only appeared once on the planet and it's diversified into an unknown number of species. The estimates are 2 million to 10 billion species on the planet. They're too hard to count. But that's not all there is to our complicated. It's not all Goldilocks effects. It's not everything. It's not a bowl of cherries. And violence, global scale and any scale, violence permeates the planet, as any of us can attest to in various ways. I'm referring to the news actually at the moment, but so that image that's up there is an image of the asteroid strike that is thought to have hit the Earth 65 million years ago. We've all heard about this. And science largely agrees that this did occur. There's pretty good evidence that an asteroid, I forget the size, it was quite large, hit the Earth, blew so much smoke and dust into the atmosphere that it made photosynthesis impossible. And the global ecosystem collapsed. That's when the dinosaurs are thought to have gone extinct. And a large proportion of life on Earth went extinct at that time. But that is only one of 5 mass extinctions that have occurred. And this is not by any stretch the largest. So that green shows the number of families of, I think, different life forms. And the asteroid is shown up there in the upper right, about to strike the planet. And that Cretaceous extinction, KT, Cretaceous tertiary extinction, which was large, probably larger than that little dent they show there. But the largest one was the Permian, which is the biggest dent in the middle of the picture there. And it's thought that 85% of all life on the planet went extinct. That, I don't know if that's can be, I don't know if that's a Goldilocks effect, I mean, we would not exist if it hadn't been for that Cretaceous extinction, which wiped out the dinosaurs and allowed mammals to radiate from very small creatures the size of mice over the last 65 million years into much larger creatures. This is a scientific story. I mean, it sounds like a fairy tale, but it is the real thing. There not only is there violence on that level, but what did you have for breakfast? You need the energy of the sun. You need to get that into your body in some way, either by eating plants or by eating animals that ate plants. So here's a lion having a zebra for breakfast. And that's the nature of the universe. Violence permeates the universe. I mean, the planet. Not only this deep perfection that we've talked about that goes all the way down to the structure of hydrogen atoms, but also there's this deep perfection and there's this violence that also exists, and both exist. I put this in because the universe adores diversity, especially the planet and life. Life has diversified, as I mentioned, from a single species, of unknown origin. Science has never been able to figure it out, to millions and millions of species, and is constantly diversifying over time. And that includes the human race. And I put it in because I think this is challenging for individuals to embrace diversity. But the point is that diversity is a natural, emergent property of life, and arguably of the universe itself. So I think we're closing in on a summary situation here with a twist. So life on Earth, including your life, because your body is made up of elements formed in supernova explosions, expresses a life of refinement and connectivity that's nearly miraculous. All life is related. This is a scientific fact. And everything flows into everything else. I didn't mention this, and if I'd thought of it, I would have put it in, but there are no more elements being delivered to, nor nutrients, which are going to be both elements and compounds, but things like nitrogen, phosphorus, potassium, the thing that life is made out of. There are no more nutrients being delivered. Everything, I mean, except for, a little meteor rain. But other than that, everything was delivered when the Earth formed. And so for life to continue, everything has to constantly cycle. And that seems to be extremely difficult for our brains to grasp. So this is that statement: everything on Earth cycles. There's no waste. Nothing is wasted. And this cycling of life and this interrelationship of life, it's known as ecology. And ecology really should be our God, as far as I'm concerned. Ecology is God-like in how everything flows into everything else. And really, I think we can find deep satisfaction and deep meaning in being able to participate in that very basic reality. Just go out and look around. This is a diagram of that phenomenon. And, it said wrong on here and right, and I took those out because I didn't like those statements. But, the way the human mind works, it's just a natural thing to feel our own sense of aspiring importance. I'm putting it that way because we struggle for a sense of importance, but it's important to us to feel that we have a place in the universe. But in fact, we are just a part of a much, much larger phenomenon that is probably equally enjoyable as feeling dominant. And that's the insight of ecology. So I hope I don't lose you here, but this is a bit of a stretch, but it's also a real thing. So I worked on a Mennonite farm when I was 18 in Pennsylvania. Those are not the Mennonites. I don't have any pictures of those people. I wish I did. And I found this book on the bookshelf called The Protestant Mystics, edited by W.H. Auden. And I found a passage in there that has been the favorite passage in my life ever since then, and that was 50 years ago. And it's just extremely meaningful to me, and it's going to come up here, part of it. And I don't know if it'll be meaningful to you because it's a bit of a leap. But we are thinking about this incomprehensible level of intricacy and interrelationship on the planet. And what does that have a meaning to us? Can we awaken to a deeper meaning? So this is a quote coming up. Well, this is a quote by a woman. I think it's said in the book, an older woman sitting on the porch. And suddenly she had this transformational experience of her world. And I've had that quote for 50 years. And I decided to Google it because Google knows everything. I decided to Google it 3 days ago, and this came up. This is part of the quote. It's not the whole thing. I'm going to read it. And I didn't know her name, but there is her name. But I was fascinated that this had been extracted by Google. So this is what she said as she sat there on the porch. Once out of all the gray days of my life, I have looked into the heart of reality. I have witnessed the truth. I have seen life as it really is, ravishingly, ecstatically beautiful, and filled to the overflowing with a wild joy and a value unspeakable. I mean, she's saying that is the summary potential of human existence, to experience something beyond our personal self. So I put this in. It's a line from Zorba the Greek. It's supposed to be lighthearted, but Zorba said, "You think too much. That is your problem." We do live in a world of thought. Most of you would agree with that. There's an internal dialogue going on all of the time. And Thich Nhat Hanh, who most of you know who that is, a Vietnamese monk who just died 2 months ago, says, if you practice awareness, your life becomes much richer. We begin to see the world around us, and we get a sense of happiness from moving out of the self and into awareness of our world. He says, happiness is available. Please help yourself to it. And that proves it. So this is one of the last slides, I have a book of quotes, and this is in there. I got it from somewhere, but I find it to be profound. Each one of us is the only thinker in our universe. The whole world that thinking has created lives inside of our heads. The actual universe is largely outside of our heads. And so quieting that thinker to be able to observe and perceive and appreciate the world is, I think, advisable. So this is from Desiderata. with all its sham, drudgery, and broken dreams, it's still a beautiful world. I thought of just to augment this, I put a passage. Some of you would know who Patty Ann Rogers, my favorite poet of all time, and I've put her poetry in the Meha Naturalist, but I put an essay by her in about 2 years ago, and she basically was just saying, this world is it's all things. It's as violent as you could ever imagine, and it's as beautiful as you could ever hope. And she said, I just try to accentuate the positive. And I thought that was a good way to express it. So that is, what did I call this? Science and spirituality. So I have a recommendation down at the bottom for some of you who might be interested. There is a song called Holy Now. And Holy Now, really, it expresses the same thing I've been talking about. It's a good song. And if you Google it, Holy Now by Peter Meyer, you'll get that song. And just for example, he says, if I can remember, when holy water was rare at best, it barely wet my fingertips. So holy water, see that, there's a little bit of it in a little bowl in church, and it's supposed to be holy, and you dip your fingers in it, and there's not much of it. And then he goes on to say, but now I have to hold my breath because I'm swimming in a sea of it. We live just in this sea of miracle. The only missing element is waking up to it. And I mean, that is the summary statement. And I might amend that by saying, I feel strongly that's true. I don't know fully how to take that step. I'm not saying I do, but I think that's the assignment for the human species, is to wake up to the miracle of the world we live in. That's it, folks. So, any counter arguments here?
Thanks, Dana. Do you want to stop sharing so we can see everybody?
Where's that? Stop share. I forget.
There you go. You've got it.
So you can unmute yourself and talk if you want to. Martha, what a treat.
Hi. We haven't been down your way in a long time. We miss it.
Yeah.
We're
So
stuck
Martha
up here in Vancouver.
Vancouver, yeah. Well, thank you people for listening in, and let's just see, well, if you have anything you want to say, Mary, hi Mary, and perhaps bye. Nice to see you. I lost my full screen. Where did it go? Full screen. Well, I don't know if that registers. It's fairly far out material, but a lot of that's science. I'm not making that stuff up. And I think our question is how we process it and what we make in our lives out of that aspect of the life that we're given. So I appreciate big history. Big history is, as some of you have heard me say more than once, but it is a discipline taught in colleges around the world now, and there is a big history class at Liberty Bell High School. So this is not far. They're not teaching what I just taught, what I just shared. But the basics. That's the basic big history story. All of that is in there, except for that quote at the end. So,
Tongue-tied.
any counter arguments?
No counter arguments. Thanks, Dana.
Yeah.
I still remember my first chemistry class realizing that the tabletop I was sitting at was not solid. It changed my world to think of chemistry and how bonds are formed. So I'm in.
You're in, yeah. Yeah, we hear that said, and it's true that solids are mostly empty space. And I don't understand that, and I don't understand many of the aspects that I addressed in the last 45 minutes.
But
I think it's beyond comprehension. walking around with a sense of wonder works just fine.
Yeah. Yeah. And we all understand that our senses are limited, I hope. And because of that, we can't necessarily feel that our table isn't solid.
Right.
So thanks very much.
Yeah, my pleasure. Thank you for listening in. Any other comments before we call it a morning?
Just thank you very much. And we're all trying to wake up, and this is a helpful word.
That's great. Thank you.
Yeah, thank you so
Okay.
much. This is a great way to start the day. Think about life in this way. Thank you.
Yeah. Glad I could get through it. Okay, see you guys around the planet.
Okay, thank you all for being here. Thank you, Dana.
Yeah.
Thank
Bye-bye.
you,